Exciting, ever fascinating with chemistry. We're looking at Dalton's law. Remember, this is the same John. Dalton is the father of atomic theory. Dalton's law states that the total pressure in a closed system is equal to the sum of the partial pressures, and our equation is equal to P total is equal to P of 1 plus P of 2 plus P of 3 plus until we get all the pressures added together. So the simplest way to do this is looking at the pressure collected over water at 26 degrees Celsius. In your book on page 1111 is water vapor pressures. I'll include that with the notes, so that way you can look that up to verify that I'm right. Barometric pressure is equal to the total pressure. So we have P total is equal to P of the first gas plus P of second gas, which is P of chlorine plus P of water. The total pressure is the barometric pressure, which is going to be 756.99 torr. We don't know chlorine, but from the page 1111, we know that the water vapor pressure is at 26 degrees Celsius, 25.21 torr. We just simply subtract it, and we get 731.78 torr. That's all we have to do for that one. Now, we do have where we can apply the ideal gas law to Graham's law. And we say we can rearrange it to find pressure. Pressure is equal to nRT over V. So we take Dalton's law, P of A plus P of B plus P of C, blah, 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 and plug it in. We get N of A RT over V plus N of B RT over V plus N of C over RT over V. And we can take RT out of V out of all those, and we're getting the equation, oops, missed it there, the equation here that we can work with, which says that the total pressure is equal to the sum of all the moles of the gas times RT over V. All right, so we'll look at a problem here. Identify the total pressure in a system with a temperature of 51.44 degrees Celsius. System contains 55.08 grams of oxygen, 44.01 grams of nitrogen, and 6.91 grams of argon in a 4.899 liter container. Calculate in kilopascals. All right, so we'll do that one in class. So if we take pressure over pressure 2 and using the equations we just get, we get N1 over RT over V over NT RT over V. Those cross out. We get N1 over N total, which, if you remember solutions, that's my mole fraction. So we can then figure out a way of finding the partial pressures by taking the pressure of each individual gas is equal to the mole fraction of that gas times the total pressure. So in class, we'll determine partial pressure of nitrogen, the last problem. I'll go up to there, we'll look at it, and then come back and do the problem. And with that, we're done. Take care, be good.